Hello, I'm Shahbaz Abid. This is General Physics 1 Lecture 5. This is going to be the last part of the chapter Motion in One Dimension, and in this lecture I'm going to talk about vertical motion. Since we are going to talk about vertical motion, which means along the height, we can now change all the x as y, and the equations and their derivations are going to remain the same. Let us see example 1. A hot air balloon starts rising upwards from the ground from rest. If the balloon is rising with an acceleration of 4 meter per second square, then the balloon height in meters after 20 seconds is. This is a suitable equation of motion we have here, and we know all the variables except the y final. So if we substitute initial to be 0 because it is started from rest from ground, so the origin is going to be ground, so initial height is 0, and we have initial velocity equal to 0 and time equals to 20, and half times acceleration was 4, and we have the time again 20 squared. It's going to give us the final height to be equal to 800 meters. When the object is moving along the height and there are no other forces acting upon it, no air resistance, and only the gravitational acceleration is in action, then the object is considered as a free fall motion. So in the case of the free fall motion, the acceleration is always constant and it's going to be 10 meters per second square. Since it is acting downward, we are going to denote this as negative g in the acceleration. The motion is independent of mass as well, so any mass will have the constant acceleration that is due to gravity. So again we had the equation of motion general in the y direction. We can now substitute in these equation of motion ay as negative g, so this has become final velocity equals to initial velocity minus g times t. And if I substitute in all of the other equation of motion the same thing, which is negative g in the place of ay, I'm going to get these equations of motion which are for free fall condition. In the equations of motion for free fall, we already know the acceleration is equal to 10 meter per second square acting downward. So now we just have 4 variables to solve any question. If I know any of the 3 variables, I can get the 4th variable from any one of these equations of motion for free fall. There are some facts related to free fall condition. When the object is moving upwards, the velocity is positive. When it is moving downward, it is negative. When the object reaches the highest point, the velocity at that instant is equal to 0. When the object is thrown upward with the initial velocity, let's say positive vy initial, and returns to the same starting point from which it was thrown, its final velocity is going to be the negative of the initial velocity. This negative indicates that the velocity magnitude remains the same, but only the direction has moved or shifted from upward to downward. So if the velocity initial and the final are equal and opposite to each other, it means the acceleration is constant. So whatever the time it took to move upward, it's going to be the same time it has to travel from up to down. So the time up is going to be equal to time down because the acceleration is constant. It's going to have deceleration if the object is moving upward, and the deceleration is going to be negative 10 meters per second square. And if the object is moving from up to down, it's going to have acceleration again acting downward, which is 10 meters per second squared. To justify these facts, let us do a case study on 2 objects that are at a height h from the ground. The object A is thrown vertically upward with velocity Vy initial. and at the same time the object B is thrown vertically downward with velocity which is equal to the object A velocity, but it is thrown downward, so it's going to be negative Vy initial. So this case study has two questions: which object will reach the ground first, which object will hit the ground with higher speed. So to do this case study, let us put numbers in the place of h and in the place of initial velocity. The h of the building, which is the height of the building, is going to be 75 meters, and the initial velocity is going to be 10 meter per second. So for the object A, it's going to be positive 10 meters per second, and for the object B, it's going to be negative 10 meters per second. Let's do a case study for object A. Now the object A was thrown vertically upward with an initial velocity of 10 meters per second. So it's going to travel first of all upward, then it will stop at 2. It will have no velocity at 2. Then it's going to travel from 2 to 3, and then finally from 3 to 4. So let us first of all find the time and the velocity for the motion from 1 all the way to 3. So I can use this equation of motion, and considering the origin to be the starting point of this object, so it's going to basically be from 1 to 3 is going to have final position to be 0 and the initial position also going to be 0, because it has traveled from the origin which was here and it has returned back to the origin, which is again at this location. 3 and 1 are at the same location or at the same position. So it's equal to initial velocity 10 times t minus half times 10 times t square. I'm going to get the time equal to 2 seconds. So it took 2 seconds to move from 1 all the way to 3. Now the final velocity is going to be equal to initial velocity minus g times t. Now initial velocity was positive, so it will be 10 minus 10, which is the gravitational acceleration, equal to 10 times the time is 2. I'm going to get the final velocity equals to negative 10 meters per second, and you can see that the initial velocity was positive 10 and the final velocity is equal to initial velocity but negative. So it means the v down is actually equal to the negative of v up, and it is equal to minus 10 meters per second. Now to study the motion from 1 to 2, we know that when the object has reached to 2, the velocity is going to be 0 because it is the highest point. So if we want to get the time, we can use this equation of motion, which is final velocity is equal to initial velocity minus g times the t up, and final velocity is 0, initial velocity is 10, and the gravitational acceleration is again 10. Negative is already substituted here. You will get the time up to be equal to 1 second, and it makes sense. The initial velocity was 10, and every 1 second there is going to be a deceleration of negative 10 meter per second. So it's going to be taking just 1 second to move from 10 meter per second to 0, because acceleration is basically what? Rate of change of velocity with respect to time. So every 1 second the velocity will be reduced to negative 10. So it was initially 10, and after 1 second it's going to become 0, so that's why the time up is equal to 1 second. And now since the total time was 2 seconds from 1 all the way to 3, and the time it took from 1 to 2 is 1 second, which means the time up is equal to time down, and both of them are equal to 1 second each, and the total time is equal to 2 times t up. Since the object has actually started from the starting point and it has come back to the starting point, that's why the time it took to move up and the time it has took to move down are equal to each other. Let's now consider a motion from 3 to 4. So at location 3, the initial velocity is going to become negative 10 meters per second, and the final position when it's going to hit the ground will become 0, and the initial position is going to be 75, which is the height of the building, and the initial velocity is going to be negative 10, and the only unknown in this is going to be t. We can see that this is now a quadratic equation. We can use quadratic formula to get us two roots of time, and we are going to choose positive time, which is going to be 3 seconds. So it took from 3 to 4 3 seconds to reach the ground. So now we can calculate the final velocity from this equation of motion, which is going to be final velocity equal to initial velocity minus the g times t, will give us the velocity, final velocity just before it's going to hit the ground, to be equal to minus 40 meters per second. We can now plot the velocity versus time graph for object A. So now we can see the variation of velocity with respect to time. So initially the object was thrown upward with the velocity of 10 meters per second. After 1 second the velocity became 0 because it is now at the highest point, and then at time equals to 2 seconds it has came to a starting point which was 1, and the velocity is going to be negative 10 meters per second, and it took 3 seconds from 2 seconds 1 2 3 to reach the ground, and it's going to have total time to be 5 seconds, and the final velocity is going to be negative 40 meters per second. Let's do a case study for object B. The object B started from 1 and it was thrown vertically downward, so it's going to have just 1 all the way to 2 motion. So now we know the final position is equal to 0 and the initial position is going to be 75. So 0 minus 75 equals to, the initial velocity is now negative 10, and again the only unknown in this is the time. We can get the time equals to 3 seconds. Now we can get the final velocity from this equation of motion, and it's going to be equal to negative 40 meters per second. We can now plot a graph of velocity versus time for object B, and we can see the variation of velocity with respect to time. So initially it was thrown vertically downward, so the initial velocity was negative 10, and every 1 second there is going to be acceleration of 10 meters per second squared. So it's going to change from negative 10 to negative 20, negative 20 to negative 30, and lastly at location 2, when it's just going to hit the ground, the velocity is going to be negative 40, and the time it took is 3 seconds. We can now combine the velocity versus time graph for object A and object B. We can now notice that both velocity versus time graph are parallel to each other, which means the acceleration for both of them are constant, that is due to gravity, and it's equal to 10 meters per second squared negative. Negative acceleration means negative slope of the velocity versus time graph. So now we can see that the slope is constant and it's negative for both of them. Both objects are going to hit the ground with the same speed, that is going to be negative 40 meters per second, but they are not going to hit at the same time. The object A has taken 2 seconds more due to the upward motion, and it is going to have a lag between them as 2 seconds. So the object B is going to reach first, and the object A is going to reach after 2 seconds of object B, but they are going to have the same final velocity, that is going to be equal to negative 40 meters per second. So in conclusion, both objects will hit the ground with the same velocity but not at the same time. Let's see example 2. A boy throws a ball vertically upwards and catches it after 4 seconds. What is the maximum height in meters reached by the ball? So now we need to know what is the maximum height the ball has reached. Since we know at the highest point the final velocity is equal to 0, so we can use this equation of motion, that is going to give us the height. Since the time it took for the ball to move from starting point to the highest and from highest to the starting point, and then the boy catches it, which is basically equal to 4 seconds, the time it took from the starting to the highest point is going to be half of the total time, which is going to be 2 seconds. So we have to substitute 2 seconds and we are going to get the height to be equal to 20 meters. Let's see example 3. A ball is thrown downward from the top of a 100-meter tall building with an initial speed of 5 meters per second. How long in second does it take for the ball to reach the ground? Initial position is going to be 100, that is going to be the height of the building. The initial velocity is going to be -5 because it was thrown downward, and acceleration is constant, that is 10. We only have t as unknown, and again this will become a quadratic equation, and we can use quadratic formula to give us two roots of time. One is going to be 4 seconds, other is going to be -5 seconds, and time is always positive, so we are going to choose time equals to 4 seconds. Let's see example 4. A ball is thrown upward from the top of a 40-meter tall building with an initial velocity of 10 meters per second. Find the magnitude of the ball's final velocity Vf just before it hits the ground. So the height of it is 40 meters and initially it was thrown upward. So in this case we can use this equation of motion because this equation of motion is not having time as a variable. So we can use this as our equation of motion to solve this problem. So we need the final velocity, that is unknown, is equal to initial velocity square minus 2 times the 10 times the final position is going to be 0 because the origin is at the ground level and the initial position was 40 meters. We are going to get the magnitude of the velocity equals to 30 meters per second. So this equation of motion actually gives us the magnitude of the ball's final velocity. So it's going to give us a positive number, but we know it's going to be moving downward, so it's going to be -30. But since this equation gave us the magnitude because it is squared, so we are going to get the final velocity as a positive number, but we know it's going to act downward. Let's see example 5. A ball is thrown vertically upward and it reaches the maximum height of 50 meters from ground. Its speed in meters per second when y is equal to 45 meter is. When the object has reached the maximum height, we know the velocity at that instant is equal to 0. So we can take that as our final velocity and initial velocity is going to be unknown. The final height is going to be 50 meters and the initial height is going to be 45 meters. We can use this equation of motion and substituting the final velocity equal to 0 and the initial velocity is unknown, and we have 50 as our final height and the 45 as the initial height. We are going to get the initial velocity equals to 10 meters per second. So when y is equal to 45 meters, the velocity is equal to 10 meters per second. Let's see example 6. An object is dropped from an initial height h0 and takes 2 seconds to travel the last 100 meters before hitting the ground. Find the initial height h0 in meters. So for the last 100 meters, they gave us the time for it to travel this 100 meters, and we can use this information to give us the initial velocity of this interval, which is 100 meters, and that initial velocity is going to be calculated from the equation of motion in which I know the final position is going to be 0 because it's going to hit the ground and the initial position is going to be 100. The initial velocity is unknown, the time it took is 2 seconds, and again the time is 2 seconds. We will get the initial velocity equal to -40 meters per second. Now the initial velocity of the last 100 meters will become the final velocity of the remaining height. So the final velocity is now -40 and it's squared equals to the initial velocity is 0 because the object is dropped. So when the object is dropped, the initial velocity is equal to 0 and we have the final position to be equal to 100 and the initial position is unknown, which is basically h naught. So we are going to get the h naught to be equal to 180 meters. Let's see example 7. A hot air balloon rising upwards with a constant velocity of 10 meters per second. If a bag was released when the balloon was at a height of 120 meters, then the time in second it takes the bag to strike the ground is. So in this case, a hot air balloon was rising upward with a constant velocity of 10 meters per second. So this will become the initial velocity upward for the bag, and at that instant the height was 120 meters. So we need to calculate the time in this case. We know the initial velocity is going to be 10 meters per second even for the bag as well, because the bag and the balloon were both of them were moving upward with the constant velocity of 10 meters per second, and the height was at that instant 120 meters. So this is initial velocity and this is going to be the initial position. We can get the time by using this equation of motion, and it's going to give us again two roots of time. One is going to be 6 seconds and another is -4 seconds, and we are going to use the positive time and it's going to be 6 seconds. Let's see example 8. A ball is launched vertically upward with an initial velocity v0. When the ball reaches a point where its velocity is v equals to 5 meters per second and is at a height h, which is half the maximum height it reaches, what is the initial launch velocity v0 of the ball in meters per second? Now when the velocity is equal to 5 meters per second, at that instant the height was half of the maximum height it has reached. So we know when the height is maximum, the velocity at that instant is 0, so we can pick that as our final position, and the initial position to be having velocity equals to 5 meters per second and the height to be half of the maximum height. We can use this equation of motion in which we are going to substitute the final velocity to be 0, initial velocity to be 5 and it's squared, minus 2 times the g, which is 10, times the final position is h max, and the initial position is going to be half of the h max. We will find the h max to be equal to 2.5 meters. Now we can utilize the maximum height, which is 2.5, in another equation of motion from which we can get the initial launch velocity v0 of the ball in meters per second. So now the final velocity can be considered as 5 and the initial velocity is unknown, and now we have h max over 2, which is the final height at which the velocity is equal to 5 meters per second, and the initial position is going to be 0 because it is launched from the ground level and the ground level is considered as origin here. So we can get the initial velocity or initial launch velocity of the ball as 7.07 meters per second. Let's see example 9. An object launched in a vertically upward direction with an initial velocity of v0 equal to 65 meters per second. The object strikes the bird that was 100 meters horizontally away from the launch point. If the bird is moving horizontally at a constant speed of 10 meters per second, what is the vertical distance h in meters between the launch point and the bird? Again, it's a relative motion question. We know that when two objects meet, they are going to meet at the same position and at the same time. So we can use the information from the bird. We know it is 100 meters away initially. We can get the time for it to be equal to 10 seconds. Since it is moving in the negative x direction, is going to be negative 10, and the final position is basically at the launch point and the initial was 100. We will get the time equal to 10 seconds. So when time is equal to 10 seconds, the object must reach at this time so that they are going to meet at this position. So by using time equals to 10 seconds, we will get the h, the height, from this equation of motion by substituting time equals to 10 and the initial velocity of that object equals to 65. We can get the height equal to 150 meters. Thank you, and I will see you in the next lecture.